All right, so, and like one of your classmates, if you're just tuning in, had asked, well, how was summer? And it was great, and hopefully you all can say the same. Thank you for asking. And I think probably one of the number one responses is always goes too fast, and I suppose there's something to that. But that's what happens when you are enjoying your time. It's going to go fast, and even if you're not enjoying your time, probably say it's still going to go fast, okay? And we did this, I think, when you were freshmen. We can look at this mathematically, okay? So everyone's age expectancy is going to be different. We don't know when. We all are born with an expiration date. We don't know when, we don't know how, or anything to that nature. So who can we pick on in here?
Present.
Okay, so then how old?
17.
That's how old you are now. Yeah. Your expiration date.
20.
You want to say 17?
How old do you
I
want?
hope not.
You're going to expire when you're 17.
Good 70.
Okay, so 70. And high school, 4 years. 4 divided by 70. High school is a little over 5.5% of your life then. Not a lot. Okay? So those who make a choice or have chosen to take advantage of the opportunities that are given to them when they go off to college, chances are they're more often than not, which means there's a higher degree of success that they're probably going to have because they made those choices. That this is what I'm going to do. This is how I'm going to behave. This is what's asked of me, so this is what I'm going to do. Okay? Finals in December. There is a way to get out of it. No opting out. No A's. Yeah, you can drop the class. If you drop the class, that will get you out of taking the final.
I'm scared.
Okay? So this is where the amount of time that you put into your physical science class and how much maybe you can remember is going to be a great benefit to you, and maybe how hard you worked at that time, and maybe you felt I worked as hard as I could, but it just was really difficult for me. Not everyone's always going to be successful at what it is that they're trying to accomplish in these classrooms. The reason, an example of that, not everyone can be the shooting guard in basketball. Not everyone can be the running back in football. Not everyone can be, I don't know much about volleyball, but to me, I would think the one that is the most vital position in a volleyball team, is that a setter? Is that the setter most crucial? Okay. So what are the chances that only one of you ladies is trying to be the setter? Everyone wants to be the setter. Does everyone get to be the setter? So is that a pretty good analogy that, okay, this is what you wanted to do, but not everyone gets to do that? Okay? Now, again, if we're tuning in later, you're going to find out as you're looking at this, yeah, there's a glare here. You've lived with it this long. You just have to move your head, move around. And typically, I think it's back there. I don't think it's so much over in your corner, is it? There's not so much of a glare. And maybe where would that start? Is that about maybe this and over? Do you too notice a glare? So, you can see it. Okay. So when that happens, yes, I got my x-ray vision. I can see that it is right here, isn't it? And right there, isn't it? See, I can do that. I got my x-ray vision. Or how am I cheating? Someone said it. Not my peripheral vision. Yeah, I can look at the computer screen. I can just say, yeah, it's about right here. Okay? All right. So, just like we've been saying in all the other classes, we know what's expected of us when it comes to mobile devices. Where is it supposed to be?
In your locker.
In your locker. Okay? And you know that. That's where it belongs. Okay? And it baffles me, not at the high school level, but at the college level. Okay? For those of you who don't know, well, there's no way you would know other than I'm telling you now. I spent a couple weeks up on the campus at SDSU in one of the research labs. Okay? Which means it's a graduate assistant that works with a professor. And that professor wasn't there because he was in Pennsylvania, I think. He had just written a grant for his research, so there was some sort of convention that he's at this trying to have his grant approved. Because when you are working at a university, your job might not always be teaching. Your job is research to make the university money. Okay? So with that, in this discussion, this graduate assistant I'm talking about, he says, and that's part of the requirements of being a graduate assistant. You might have to teach classes as well. Excuse me. It's always this first day. I don't talk this much over the summer, so it's a little hard on my voice. So anyway, so he's sitting in these college classes while looking at students, and this is what they're doing during the lecture. They're probably just doing this.
Their phone.
Okay? So, in his experiences, what's the success rate for students who choose to do that? Not very good. And you know, what's the difference between taking this chemistry class and that chemistry class up north? About $1,000. But maybe some of you have no problems paying $1,000 at a time. Could be. I don't know. And I don't know if it's quite that much. I want to say, would it maybe be $170 a credit hour? We'll just say that. And chances are it's probably not 3 credits, it's 4. I got to get enough light on this solar powered calculator. So 4 times 170, it's not going to be as much as what I thought. Well, that's still $700, but you still have lab fees and other types of fees. So it's probably about $1,000 for that class. So you're closer to that age. Can you explain to me, you're paying for this and you're in a college class, why would you sit on your phone? Probably. They're addicting. Okay. Would someone maybe learn really quick that maybe this isn't, maybe I shouldn't be doing this? Now you might say, well, that person probably still passed with a C or a D. Is that a problem?
I mean, depending on what you're majoring in.
It can depend upon what you're majoring in, because if you are trying to get into a particular program, and if you have a C on your transcript, they're going to say, you're not getting into this program. Yes?
So if you drop out of a class, are you still having to pay for that?
If it's the first week and a half to 2 weeks, you can drop it with a full refund. If it's within maybe 3 weeks of the end of the course, you drop it, you paid for it, but it doesn't go on your transcript. You withdrawn from the class. That's my understanding. And some people may still choose to do that because they can't have that on their transcript. You do, you're going to have to start over again anyway. Okay? So it's those types of choices that we want you to be making. It's not us being mean saying, my gosh, why are they saying we can't have these devices? Well, we want you to be successful and be self-sufficient once you leave this classroom. I'm not going to follow you to your next classroom. I might step outside and someone, there's some face walking down the hallway. Well,
Expelled.
we'll go ahead and confiscate that and then let the cards fall where they may with, let the administration deal with that. So, but the main point is, you know you're not supposed to have them. Yes?
What's the punishment for sneaking into a college class?
There is none. There's no punishment for that.
So you can literally just go and sit through college classes?
My question would be not only why, but if you're doing that, where's this person supposed to be that's sneaking in?
They're unemployed. They're just.
Well, it's probably not going to take very long, and you're just going to be recognized, especially if it's in a lab. They're going to say, you have not paid for this course. What are you doing here?
I'm a foreign exchange student.
Well, then you should have everything taken care of, registered, and paid for. That's probably one of the biggest things. The college, their university, yeah, you can sit in on that, paid, but I would think after 2 or 3 times, there could be assignments at the end that you got to turn in. And you might say, well, they could still turn in an assignment. But then when they go to the grade book, who's this individual?
Like, what if they sat through all the classes and they learned everything and then they
It's not going anywhere. Registered for the class, it doesn't go anywhere.
Yeah.
Right.
No, exactly. It's one TV show like the Harvard Law
it,
Review.
and then they come back the next year and they know everything.
Yeah.
Do you ever watch
I think that is a hypothetical situation that it's one that I really can't answer, but that is the best one that I have. Okay. So, moving forward, it says properties of elements and compounds. Okay? Well, when it comes to bonding of compounds, let's see what we remember. 2 types of bonding that takes place in compounds. Well, all of them are chemical bonds. You're going to say, I knew that if I just tell you.
Wait. I know oxygen bonds. Acidic bonds.
Well, again, hydrogen bonding is true, but that's only for a small part of the molecule. We want the entire compound. So you're not entirely wrong, but you're further from being correct than what you are wrong. No, they're all chemical bonds. And once one says one, they're going to say, oh, that's the other one.
Gold bond.
Double bonds.
Nope.
Singular bond.
Nope.
Wait, what was the question?
What kind of bonds?
Okay,
Covalent bonds.
that's one.
I got it from Sarah. That's not me.
What's the other one?
Sarah got died.
Diesel.
Nuclear bond.
Yayo.
Okay. What might be possibly what sticks out in your mind? Look at those 2 compounds, okay? And when we look at their arrangement on this handy-dandy tool, this table, how many of you still have your freshman physical science, freshman periodic table?
I believe that was.
I think I do.
Okay,
Somewhere in a folder.
all right.
I probably should.
Well, who can we pick on in here?
You can pick on me.
Okay,
No.
since you two I would like this back. Okay, so look at the entire compounds in general. Okay, whether it's the top or the bottom, one of those is ionically bonded, the other one is covalently bonded.
Top one's covalent.
No,
Top one is ionic.
I had a 50-50 shot and I flew it. You suck.
Okay, so now that we've established that, when we say chemical bonds, hydrogen bonds, yes, those are just small parts of the bonding that takes place in these compounds. But what is it that makes the top one ionic and the bottom one covalent? And what I want you to think about is, notice this is a long drug-out compound. Okay? So we could say this is acetic acid, we could say this is vinegar. Either one of those would be fine, because when we say acetic acid, that's the major component that would make up vinegar. Okay? Just like for those of you who maybe aren't so concerned about name brand materials like Tylenol. Some people may choose to take, I'm just going to do the acetaminophen, because for 500 caplets of Tylenol, it's $12. For 500 caplets of acetaminophen, it's $6.50. I don't know how accurate that is, but again, some people maybe just feel more comfortable having the name brand, which is fine. So that's what we mean by acetic acid and vinegar. But this compound has something that this one does not.
Sodium.
Why is the sodium significant?
Light material?
Hydrogen's a light material too.
It's the.
So now, there's always exceptions to the rule, which I need to point that out first. It's the placement of these elements on the periodic table. So remember we said this has something that this one does not. Okay? So we said there's exceptions to the rule. This and this. Those two have something very significant in common.
They're both +1.
Okay, plus one, you're getting closer.
In the same column.
Yeah, they're in the same column. So what that means then, chemically speaking, okay, how many of us remember this?
Ooh. Oh no. No. Valence electron, it has one valence electron.
Not the Bohr bottle.
Okay, then,
The Bohr bottle.
okay, you might be asking yourself, if this is ionic, notice we put these two in a box here. This one's ionic, this one is not. They're in the same column. This has a +1 charge. This has a +1 charge.
because there's
But why can't these both be ionically bonded? Again, think of the components of what's the difference between this and this. It's not the charge, it's not the valence electron. Well, they're in different energy levels and in different spots, that's true. But think of what comes to mind when you think hydrogen.
by itself.
True. And I understand the way we're asking these questions is probably pretty difficult. I have no idea where you're trying to point us in this discussion. But that's what makes this a tough class, because you're going to be responsible for this content. I'm presuming we're in this class because we're going to be taking this in college. If we're doing this class just to fulfill your graduation, that's great, but you're making it difficult. I'm not saying that you have to drop this. No, that's exactly what we're not saying. But one of the biggest reasons that, or indicators that I think a person would take this class is because this is very similar to what you're going to be experiencing in college. Okay? So What type of substance is hydrogen? That is a gas. What type of substance is sodium? It's not a gas.
It's a powder.
Sure, it's a solid, but there's different types of matter on that organization of the periodic table. We already established some of these are gases. Mercury and bromine. Sorry about that. I don't even know when this went dead, so chances are maybe about 10 minutes into this, all of a sudden you see talking and then there's no sound coming out. But last thing we're going to mention, okay, we're not going to start with this, but this is what I mean by giving you the tools to be successful, okay? Because what happens when we talk about, chemical reactions, do we remember those? Okay? Because one of the things that we say, we give you the tools to be successful. Now, you don't need to write this down. You can, but I have a feeling if you do that, it's really going to confuse you. Okay? So the way that chemical reactions have changed, the chemical reactions haven't changed, it's the way that they've been taught, okay? Whether you say this type of reaction, do we remember from physical science, what type of reaction might that be?
Sodium bicarbonate. Yes.
This is a combustion.
It's not a combustion.
Plus.
So it's not this one.
It's not the decomposing.
It's not decomposition.
Oh, I have
It's
these
the
in
one
my
where it
older book, but
combines.
I
It's
don't
the-
know where it is.
I know what it is, but DR.
That's a double replacement.
Single
That's why.
replacement.
It's not a single replacement. There's your reaction, okay? So one of the things that you look at is to see how these have changed, okay? Because this was a solid, this is a gas. You put the two together, notice you don't have a solid and a gas over here. So those are different types of reactions that we call oxidations and reductions. That is part of this curriculum as well. This is probably 3 steps further than what you learned in physical science. Okay? Is it a lot to take? I would say this is a lot to take in the first day. There's no doubt. Okay? But this is further down the road, but I just wanted to show you an example of some of the things. Some of you are going to have to sort out different types of materials that when you get to college, you might say, we didn't learn this in high school. Okay? But we give you enough of a background to leave you a trail of breadcrumbs that you can figure this out. Okay, that's all I have. We'll catch up to you next time.